Hey, now, Yannis, thank you for coming in. You're doing a marvelous job. You got this tremendous history of success, outstanding accomplishments, and this is continuing. And now you've been in the role of president of the ACM, Association for Computing Machinery, which is the world's largest computing organization. And in my opinion, and I would say the world's opinion, is not ranked #1 in computing science globally as a nonprofit. So we're going to mine some of this, and but I'll first start off with, maybe you can give me some updates of what you're doing in your professional life outside of ACM, and then we'll focus on what's happening with ACM.
Okay, well, let me focus on 2 or 3 things that I'm doing scientifically. Let me, one of the things, my main field is data management, databases, and this is most of my scientific contributions, my research contribution, that's the area. And the current thing that I've been working on with colleagues and students is a particular attempt to go over the problem of impedance mismatch, as it is called, between the SQL language, which is the predominant language for databases and data processing, and programming languages, which are they're universal, they're Turing complete, whereas SQL is not. And but nevertheless, they're not as scalable, they're not as since they have to deal with general things, they're not they don't have the structure that SQL offers. So on one end, SQL, whenever we have to deal with data using SQL, is very good, and technology that has been developed in the past 40, 50 years gives us scalability, speed, optimization, and so on. But that's not Turing complete. So there are a bunch of things that we need to do with data that cannot be done in SQL. So we have what is called a user-defined function, or many user-defined functions that are expressed in a Turing complete language. And the flavor of the day, or of the last few years, let's say, is Python. So many people express Python, especially machine learning applications and other applications. Now, how do we bring together user-defined functions inside SQL? And all systems offer you this capability. But in terms of performance, things suffer. So with my team and colleagues, we're working on to employ a lot of existing technologies, and even devise some of our own, to make this match, to make this dance between a programming language and SQL as fast as possible. And we've been able to achieve tremendous progress in this direction, winning over on performance and benchmarks all the other efforts that exist there, both in the research field, but also from commercial providers. And we're mid-flight. Our work is not done, but it's very exciting because not only we do the way we approach this with focuses on performance, which is what everyone is thinking about, but also with a particular language that we have, which is a fusion of a programming language like Python and SQL. We have high expressivity, but also usability. So the programmers, after they get over a learning curve, they are able to program much faster than using separately Python and SQL and so on. And interestingly, for many years, the path that the data management world was going on was for the initiative, or if you want, not initiative, but anyway, the approach was called NoSQL. So don't use SQL, use programming languages and so on and so forth to do everything. We call our initiative YesQL. So you extend SQL, it's still an acronym, but also we are going against the NoSQL background, and so far we work. So this is one thing that I'm really excited about. with respect to my research. And if I may introduce there as a second one is the element of completely different thing, interactive digital storytelling. It's something that actually we have discussed in the past. I've mentioned it. How do you convey information and knowledge to people? Not just as dry knowledge, but embedded into a story. And cognitive science tells that this is one of the most effective ways to do this. And we've been doing for many years digital storytelling in museums. So convey the knowledge and background and history that exists in museums, or the art and the artistic thought, to visitors through digital storytelling. And we've done that besides museums in archaeological sites and modern museums and ancient ruins and so on and so forth. And this now we're trying to expand into the educational background, to educational topics. How do we achieve that, both locally, but also with certain opportunities around Europe? How do you capture this? And especially, how do you do it to underrepresented parts of the community? Storytelling has been with us, from the moment that humans walked on Earth. It's the main way that knowledge was transferred from one generation to the other. And it still works, and our brain is very much attracted to it. And in that sense, there's new openings that exist in using digital storytelling with a bunch of technology that we have been developing with my team is really really exciting. Trying to see it expanding to the educational field. There are also other strands in my work, like federated learning over private data, either the hospital or of various companies that they want to keep their own data private. How do you do that in a privacy-preserving way? Or things about the environment, and how do you become a platform for data modeling, digital twins, open science. So I have been blessed with a very large team and extremely talented colleagues and team members, both junior and senior, that we're doing different things, primarily around data, but not only, in its various applications. So I just mentioned two of the things that are very exciting. Not that everything else is not exciting also, but as a summary, let's say, with a couple of highlights. So there's never a dull moment.
There's been a lot of development since we last talked. And for example, OpenAI releasing their GPT-3 plus, 3.5, and then became 4, and now it's GPT-4 Turbo with Vision, and Microsoft, of course, embedding this into their Microsoft 365, and it's part of Copilot, which is their search
programmer.
So what are your thoughts on the intersection of these large foundation models, large language models, and their proliferation, and then the work you're doing on the data side, on the narratives and storytelling, and so on? I mean, it's going to have some impact, right?
Absolutely. Absolutely. Let me mention a couple of things, and let me start from the storytelling. The key thing is storytelling is an artistic process. So even in a museum, a curator knows what is displayed in the museum, or the expert. And then we bring in creative people, writers, illustrators, musicians, actors, and so on. So that based on a script and a staging in the museum and so on, you create a story. And then when the visitor comes in, the story is delivered to you with all its plot and musical embeddings and so on. Writing the story is the biggest part of our technology. How you can allow people who are not, Spielberg or Cameron, or the Coen brothers, to write engaging and interesting stories in the particular context. And it takes a lot of effort in that to understand what works and what doesn't work. And large language models will be extremely helpful to offer not advice, but help on the script writer, possibly even on the stage, the way it is made. Someone says, "Write a story for you." Yes, that will be, for the time being, as interesting as a human written story, as a human written script, but as a helper of the script writer, I think will have tremendous impact. So we are already discussing on our story writer part of our technology, how we can embed large language models, and that will create interesting plots or parts of plots, and will help the writer. And I think this will be an amazing strength in terms of not so much coming up with more interesting stories, but in enlarging the pool of people who will be able to write interesting stories. Because not everyone is as I said, as creative as some of the giants of creation, but that will have tremendous impact. Now, the key thing is for these large language models to be taking into account the actual truth that the body of knowledge that they're trying to convey. So what is true about every single piece in a museum, and all the background of every piece or every artist or every historical context. And current large language models, because they get all their data from the web primarily, may have lots of faults and hallucinations and so on and so forth. But bringing in the inner data, something that's called RAG, the inner data of an organization like a museum or a school or a school book, which is ground truth, together with what else the language models have, can create very truthful, but also very exciting scripts. Help the writer. So I'm really excited about this prospect. It will have, I think, a great impact in what we're trying to do. If I were to give a second example of large language models in what I'm doing, I will mention, they may affect many of the things, many of the strands of my work, but let me mention one thing that I'm working on in a startup that I'm involved in, which tries to have data-based, AI-based public policy consultation or business strategy consultation. And there, the thing that this small company is doing is analyzing lots of text, also structured data, and from that tries to explore and extract tremendous data so that consultants can come up with reports that are not based on traditional techniques like having a questionnaire and interviews and so on, so which gives you a lot of qualitative things, but take advantage of the vast amounts of data and text that exists, specialized and non-specialized. Having a large language model here, I think, will have tremendous impact as well, because lots of the things that are being explored in this corpora of text, whether it's patents or reports from companies or policy documents or whatever around the world, the large language models, they will be able to analyze them in a way and also generate parts of the report that then the actual consultant will have to verify and collect. It will be a tremendous boost. Education also in the classroom. It's not my research. For the first time this semester, I always give assignments to students, and then I say, if what you do is not yours, you haven't written the code yourself, then you'll be kicked out of the course, even if you do it in one assignment. I'll catch you, with the automatic ways and interviews, and you'll be kicked out of the course, of the class. Now, I had 3 assignments in the course I gave last semester. For 2 of them, I did the same thing. But for the 3rd one, I said exactly the opposite. You will develop the code using a large language model. And if you write any code yourself and you don't generate it by prompt engineering that, then you will be kicked out of the class, to get them into the atmosphere of using the large language models. Because in the future, I see prompt engineering being the next abstraction level of programming. I don't know when we'll reach that, but I see that as one more level of abstraction in the way people program. I mean, we started from machine language and assembly, and then we moved to Fortran and Lisp and Algol and so on, and then we move forward more and more abstract. Well, I think what these large language models give us is the next level of abstraction of programming, so I wanted to incorporate it into my classroom. And I think as in the next few models will be coming up, and we'll be getting used to it, I think that's the way it will be done. So I think it will have tremendous impact on education, including software development education. Well, let me stop at these 3, because as you said, it will be universal impact.
So in your use of large language models, these large foundation models, are you using any of the open source models that are out there, like Falcon or Llama 2, or the stuff from Mistral, or Orca 2 from Microsoft, Phi 2, some of these models that are out there? Open source, or is it a mixture of sort of from commercial?
It's a mixture. I have to say that for the time being, all my efforts, first steps in efforts with large language models have been with ChatGPT 3.5 and some tests with 4, and with Llama 2. So it's a mixture of both worlds, and it's we'll see what the world will decide to use. Opening up, how should I put it? I'm extremely excited with the technology. I'm really jealous of the people who develop these things, and I wish I was in one of those teams. Honestly, I mean, it's a tremendous leap forward for our technology. On the other hand, we are like kids playing with a knife, and we are very excited, but we don't know exactly how to use it, and we may, in addition to all the great things we can do with that, it may be, I shouldn't say dangerous, but we have to be careful with where we use these tools. For example, opening up a huge large language model, it is not inconceivable that it can be used maliciously to spread fake news, or to implant in them things in a way that they will be spread around, things that eventually may come back and harm us. So I'm all for openness. I mean, I'm Mr. Open guy, open access, open science. It's something I've been working on for more than 15 years. But openness as long as it's not universal and as long as it's not noble and angelic, may have some negative consequences. And as a society and computing industry, especially big tech, has great responsibility to give us all these wonderful gifts, but also be aware of the dangers and let us all together proceed forward. And how much open should things be? I mean, free versus open, this is not a different thing. I mean, you can be free without being open, or you can be charging even if you're open. It's an orthogonal, more or less issue. But yeah, the jury is still out on whether we should be doing these things openly or not. And policymakers have a responsibility there next to big tech and small tech and academia and everything.
Yeah, it's a you see these multimodal models, right, which can combine understand graphics and text, and there's this embedding a bit or understanding video, the work on video, just sort of all of the different modalities that are out there where they can integrate all of these into how they function and how you can prompt them and so on. In fact, earlier this year, Microsoft released within their Copilot the ability to create these little songs. And not only does it write the song or the lyrics and the music, but actually has an artist, sort of a made-up singer as well. So it creates the entire, all of it, the music, the lyrics, and the singer. And you could define the kind of music you want. You could say it could be rap or it's a ballad, and it creates this music, and it's quite.
I haven't tried it, but it is tremendous. It is it's very exciting, and the sky's the limit. We don't know how far we can go with artificial general intelligence. I mean, this is where it's going on. It's coming to the most creative of human processes and human endeavors. It's yeah, it is. We live in very exciting days, and as I said, as long as we don't. As long as we are not carried away with the excitement, but also take a step back and try to keep only the good things and protect from any possible misuse, the world will be a better place. But we have to tread carefully.
Yeah, and then combining that with different aspects of machine learning, and you see these announcements made where they're entering into portions of a math Olympiad. So they're giving it the same kind of problems, and it's solving at almost the winner kind of level, right?
Level, yeah. No, it is amazing. It is amazing. It's I don't know. I mean, AI has gone up and down through the decades in terms of being on its high or its low. And a few years back, under some definition of a few, I don't think anyone was expecting that we reach this level of creativity and generative ability by a machine. And now it's there, and as I said, excitement sprinkled with caution.
Do you think that we're seeing the early signs of AGI, artificial general intelligence? It's not human, but it's sort of very human-like in terms of capabilities, but it's not human. It's machine intelligence.
Well, I mean, we are going in this direction. I mean, Meta declared, that it's putting great efforts in that, and it says it will be open and so on. And the other big players in this are moving in this direction. beyond a certain point, the question of what is intelligence comes to comes at the table. I mean, if a machine is intelligence a concept that can be attributed to a machine, and is there anything that will separate huge computational power with huge amounts of data from a human? I don't have an answer. We're certainly going into AGI. I'm sure we'll reach tremendous levels in the next few years, again, under some definition of a few. I don't think it's tomorrow, but will it be in 3 years or 30 years or 13 years? I don't know. But lots of things that are considered now impossible by machines, I think we'll see them happening. And I hope we'll be ready and mature in our, how should I put it, in our in our spiritual and psychological depth and our policy frameworks to really enjoy this tremendous power and ability that will be coming in our way, and we'll be taking advantage for the good of everyone. And we won't allow any misuse that will be destructive. And I'm optimistic. I think we can do it as long as we all are aware and we put our minds to it.
So we have exascale supercomputers. They've been released now. They're working. New ones coming on globally. Those are ones that could do a billion operations per second. And zettascale will be maybe within the next 10 years. You'll have zettascale, 1 trillion billion operations per second.
Yeah,
these systems are so powerful. And in fact, if you look at if you use sort of a reduced operation aspect of it on the AI side, you can get maybe 100 exaflops now, AI exaflops, right? So, which is quite amazing. If you look just on the AI side, and you're not going to the full floating point representation, and you're using some sort of subset of that, then you can even get more performance out of there. This also then allows you to simulate the brain in its entirety, and there's now projects to really work on its entirety, and you're working on one, the European Human Brain Project. Can you bring us up to date on what's happening with that because of all of this power, computational power that's out there?
Well, there is the top 500, the list of supercomputers, and you're absolutely, as you said. Now we have exascale machines, and these are the publicly existing machines. Maybe there are even machines that are not public, and various governments have access to, and it's continuously moving forward. I cannot definitely much AI is being done on these machines, and as I said before, the current artificial intelligence that we have is tremendous computational power with tremendous amounts of data, and the right inference algorithms, of course. I don't want to oversimplify things. And I see I see steady growth in what can be done, and but I also see, if you want, a different direction that is, of course, quantum computing, which is a whole different level of computing. But also one more that is called neuromorphic computing. So the more we understand about the operation of the brain and how it moves forward, the more people are able to come up with particular types of neural networks. One category is the so-called spiking neural networks that are trying to capture, in some sense, how the brain works or how we understand the brain works, because this is still on the way. And in certain applications and certain areas, that seems to work much better with less power. Of course, it's specialized hardware, like quantum computers are specialized hardware. Neuromorphic computers are also specialized hardware that do these things. And so I don't think that the supercomputers will ever be phased out because they're general purpose and they do everything. But I see specialized computers that will do things that even the largest and fastest supercomputers will not be able to do on AI. I mean, just to give you an example, which is not AI, it is amazing that multiplying two numbers is extremely fast, even on your laptop or your watch, let alone a supercomputer, but extremely slow in a quantum computer. On the other hand, if you have one number and you want to find its factors, the supercomputer, struggles. It's a very complex problem. But for a quantum computer, this is kind of easy, relatively speaking. So you have different specialized things, and this will turn out to be the case also for AI things, that quantum computers will be the horse that you will want to ride, or neuromorphic computers, because there is, the brain, neural networks, and so on may be affected that. And then you have supercomputers. So we'll have a suite of options. And then whatever part of the AI algorithms and AI techniques are appropriate for each one will be sent there. This is an analogy. I'm generalizing and maybe taking a leap of faith here, but of something that we already see in terms of specialized chips and accelerators. We used to have CPU, and all processing was done in CPUs. And then because of graphics, GPUs came along, and then FPGAs, and then a whole bunch of other accelerators. And one of Intel's chips, I don't quite remember the particular one, has 46 accelerators. So it has a CPU, it has 45 other things that are specialized to do very fast something. And now, I mean, the entire, if you want, software stack could change, because you need to take into account for everything that you're doing, which accelerator to send it to, and not just to CPU blindly. And in the same sense, I think with the tremendous power of supercomputers and the different specializations that we see, and who knows, maybe we'll have other types of computers as well, different parts of big AI can be sent to different ones. And that would be another optimization, difficult optimization problem. So it will give us some job security. So large AI may not be able to come up with the right optimization algorithms for this for some time. So we'll still have some work to do.
So what I'm hearing then is you're seeing this sort of future of hybridization and confluence of quantum computing, let's say photonic computing, supercomputing, exascale, zettascale around the corner, and let's say within 10 years, a neuromorphic computing using a resistive RAM or some kind of Farah-based RAM, which is persistent. You're also looking at maybe analog computing in there as well, together with.
That's a good question. Yeah, that's a good question.
And then will be tremendous progress that's being made in semiconductors, and there's graphene and carbon nanotube plus 3D architectures. And so really it's the confluence of all of these things coming together that will allow very interesting problem solving, but more complexity in that problem solving as well because of these accelerated specialization that's occurring. So that's an interesting world that you're in, and you're leading in some of these areas because you're part of the European Open Science Cloud, you're part of the European Human Brain Project,
Yep.
You're part of the European Strategy Forum for Research Infrastructure, you're working on Global Climate Hub with the UN Sustainable Development Solutions Network. I mean, there's a lot of things that you're part of, including this research initiative at the Athena Research and Innovation Center, and of course at the University of Athens, all the things that you're working with there, and then all of your work with the nonprofits like the ACM. So let's now talk about the ACM. And you're also an IEEE fellow, so an ACM fellow, an IEEE fellow. So you do things with the IEEE as well. But you are currently the president of the ACM, and now you're into your last year, but I believe you're up for president again, right? So yes. Talk about what's occurred since we last talked on terms of your ACM presidency, and you had these, ACM, 3.0, 4.0, or 2. The next evolution of ACM, where that's progressing, and then what your plans are going forward. So tell us your journey with the ACM as president.
Yes, you're right. I mean, the last quarter, it's 4 semesters, 2 years at the term, and I'm in my last quarter for that. And let me start from ACM 4.0, that this was my initiative that I started. I conceived and I started talking about it after a few months after I took office. And it involves 10 presidential task forces that to be formed when I conceived it, on 10 different things that I felt and others felt and agreed that ACM needed to change and pivot so that it can serve its mission for the next, 25 years. And because it was the 4th quarter century of life for ACM, because in 2022, when I took office, ACM became 75 years old. I called it 4.0, so it's the 4th quarter century of life. And the various task forces, some have to do with our members, globalization to increase our footprint, youthification to bring in more youth, the young professionals, and a new membership model, reconceiving our structure. Also, some about services and activities of ACM that affect the whole society. It's not just within the membership. One of them being our code of ethics, and how our social responsibilities, since what we do changes the world and affects people's lives from 24 hours a day. How do we actionalize our code of ethics, which is great, and apply it in our everyday lives? And also the United Nations Sustainable Development Goals, and how ACM can catalyze the contributions of members to efforts around the world about achieving the Sustainable Development Goals. And also our product portfolio, open science, a very big issue for me and for many. How do we bring the scientific endeavor, the research endeavor into openness, and we apply the methodologies of open science, and ACM can play a very pioneering role. And a few other task forces on our internal operation of ACM. And the various TTFs there was also an open call for volunteers for these PTFs. And more than 600 people from around the world raise their hands and say, hey, I'm here, how can I help, and so on, which was given experiences with such calls, it was very pleasantly a great surprise for the number. I mean, I wish there were 6,000 or 60,000 volunteers, but even 600 was more than I expected. And the various PTFs are at various stages of development. Some have started their work, some are being, some on the membership, and some, you know, they are have chosen the chairs, but not the members yet. So there's 10 of them, and it's all together. It's too full of a plate, overflowing. The plate is overflowing. But they are on good track to start working. As I said, some have started, and to give us the results that we want. For some of them, in parallel with what the task force will do, and the chairs and members will lead. For some of them that haven't really started working, by coincidence or circumstance, or because of my own initiative, already some things are being worked, and in some cases you have really helped. For example, being in touch with the United Nations and various organizations within the UN, which are instrumental in the task force about the help with the achievement of the United Nations SDGs. And so with various discussions and I shouldn't say promotion, but anyway, campaigning on the concept of how this effort, how can ICM members join forces with industry, both computing industry, but also domain industry, can get together and offer some of volunteer time, and also maybe some granting time, some time, some grants to go after a particular big topic, possibly regional, possibly global, and that is intimately related to the 169 targets of the 17 SDGs. And I had to make a point. More than 70% of the 169 targets are computing related. They cannot be solved. And none of the SDGs as a whole can be solved without computing. So this is important, and I think ACM can play a huge role, and that's what I've been trying to do, even without even before the particular task force starts its work. And incidentally, about this, I attended the COP28, so the climate summit in Dubai in late November, early December. And I was participating in a few panels there. I gave presentations, not with my ACM hat, although the ACM hat was there, but I did not go there as ACM. And for the very first time, I actually posted some posts on LinkedIn and so on about this. It was the very first COP where digital technologies were at a certain stage. In the previous one that I was, which was last year, but also from what I understand from those even before that I did not have a chance to attend, the talk about digital was on the sidelines and not really very important. And in my first COP last year, I was making an effort to say, hey, yes, all this is great, but you need the digital technologies and so on. This time, I didn't have to do anything. Everyone was talking digital. Certainly AI and the large language models had a tremendous impact, and suddenly all realized the tremendous abilities and the impact that they can have in the climate change mitigation and adaptation. And of course, you know, ACM and all these efforts came to play, but I was really, I came out of this COP really optimistic because finally everyone seemed to understand that we need computing, we need data, and we need digital technologies. And so I feel even more poised to bring ACM to help in this direction. What else? Well, this is roughly, let's say, a summary of ACM 4.0. Let me say one more thing that I've been doing as a president. I have been trying to travel the world, so to speak. It's a big place, though. I have been in there's a lot more of it for me to go to, but I felt from the very beginning that ACM as an organization, and certainly the officers and the president, first and foremost, should be going out to the community, should be going out to society. The reverse will not work. So I've tried to go to the 10 biggest ACM conferences, which, you know, can range from 1,000 attendees to 15,000 attendees, and sometimes even more. And so I've been to most of them, and also I've been to many other non-ACM events, and also talked to various leaders from other professional societies and leaders of academia or industry, and some of them, again, thanks to you, Stephen. You've opened some doors and tickled some connections that I believe have been very enlightening for me, and hopefully they will be instrumental in things that we can do for the community and society later on. And in all my visits, again, of course, North America, Europe, Asia, in many places, Australia, and then hopefully in the next few months, and the plan is for Latin America and hopefully Africa as well. It's I've been going and giving talks both about technical things that I am doing in my research and ACM in general, or particular things like open science. And whenever I have an opportunity to talk about one of these things, I also tag the other thing. Oh, you want me to talk about, let's say, the user-defined function SQL? Fine, but how about I give a second talk about ACM or about open science and so on. So this has a these trips of mine have multiplicative effects in universities, in research centers, and so on. And this experience has been extremely rewarding, extremely gratifying, because it's extremely educational for me. I hear what people are concerned about, which could be something that I've thought of, but often it's other things that I hadn't. And this increases my level of understanding of what ACM may do as next steps, what people worry about, what people are excited about, what needs are served by ACM and what needs are not served by ACM. And also, this is not different around, it's not the same around the world. I mean, people in Australia have different thoughts and needs from people in China or in Singapore or in San Francisco. And so how do that diversify this and serve all of them at the same level on their different needs, and is a challenge. And as you mentioned, I have been asked by the nomination committee to run for a second term as president. And I have accepted because I feel that the size and extent of ACM 4.0 and all the other activities that all feed into 4.0, but also are stand on their own of meeting and communicating with the community around the world. I haven't been able to bring it to a certain level of maturity or even completion, and I decided that I want to continue if I'm voted in. I mean, it's a volunteer position, and I'm willing to invest additional time and contribute my additional time based on what I've learned so far, so I can to really bring it to fruition. So yeah, I'm looking forward to the election. A great colleague is the other candidate, and hoping that I will elect, I'll continue my work and intensify it in the directions that I said based on what I've learned so far.
So what I'm hearing is you've made good progress, and you want that progress to continue for the next vision of ACM, which is ACM 4.0. And that reflects the fact that when you came into office as president, ACM was celebrating its 75th anniversary. So the 4.0 represents the fourth quarter of the next 25 years. And this is the vision for the next 25 years, and that's why the ACM 4.0 representing that fourth part of the 100 years anniversary, right? So, and you've undertaken these major initiatives, 10, which has never been done before. And so that's why the continuance of your presidency.
That's why I decided to I think it makes sense, and given the investment and the excitement of everyone, I mean, everyone is very excited about 4.0, and not the difficulties, but anyway, my difficulty is to run with it faster. I decided that I need to serve more, to serve another term, if the membership allows that, of course, because it's something that the community has been behind it. And if you want, I owe it to the community to continue this effort and bring it to make it come up with results that will really change ACM. And every task force is a different beast, and some of it may conclude faster, others will be longer term. But I think that the initiator of such a big initiative owes it to the initiative itself and to the community to continue the effort and bring it to a level that we'll all be happy with. So I look forward to a positive result so that I can do this for ACM and in general for computing professionals around.
Well, it's a marvelous vision and journey, and really an outstanding goal for ACM, but also it impacts the world. It's a major contribution to the world because the ACM is a major player in terms of where the world is going. And as you indicated, computational aspects are embedded everywhere today. It's not just isolated. You can't be successful in any endeavor today without embracing the computational aspects of things are going. So there's only one final question. Do you have a final recommendation to the audience in closing?
Well, this I hope it won't sound as a cliche or a platitude, but be bold and whatever thoughts and ideas come to mind, no matter how offbeat they may sound, or impossible, or fearful. Don't be stopped by any of that. Bring them forward, and if you feel strongly about them, pursue. And even if you're not met with accepting ears, and if you believe in it, go after it. And only good things come out of it, even if it was a bad idea, even if it was the wrong timing or anything else. Just experience that one gets from this is tremendous arsenal for the next idea and for the next step. And the same thing, I mean, we see it, to bring it home on digital technologies. Could this be done like large language models? I mean, some visionaries thought of that, and little by little they built it. The neural networks people who were offering a few decades back a different way of approach to AI were set aside. I mean, they were not considered as core. And then a few decades later, they got the Turing Award. Failing is not a goal, but being ready to fail is a goal. And I would say, be bold and move forward. And you can do that in every aspect of your life, including your scientific life, your digital technology, and so on. So that would be a closing recommendation on anyone.
So really capturing this idea of being a dreamer but doer as well, converted into action, stretch goals, looking at pushing the boundaries and taking those boundaries and advancing further, and being committed to execution as well, right? So dreamers into doers, imagination to action, and there you can do things that are tremendous to the benefit of humanity and the benefit of all Earth ecosystems. So Yannis, thank you for coming in and sharing many of your insights with our audience and your outstanding vision. And just marvelous the contributions you're making on a continuing basis. So thank you again.
It's a great pleasure. Thank you very much, Stephen, for inviting me over.
Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the Brand Called You.